Okay, MPI communication, sending and receiving messages, between two processes. Okay, topic to cover message data type and also MPI, either point-to-point or collective. Okay, common in MPI environment, multi-process are created. Second, processes communicate with other process. Okay, third, communicate by passing messages to other process. This is called message passing mechanism, and the MPI is the library that supports its implementation. Okay, data type used in the message has to be MPI data type. The MPI data type are defined in the MPI.file. Okay, so this is MPI basic data type. Okay, all right. And then category of MPI communication. We have a point-to-point and also collective communication. Point-to-point communication, we have communication between two processes, one-to-one. Both processes are the same communicator. Sender and receiver are identified by their rank. Okay, type of the communication, either synchronous or asynchronous, and also blocking or non-blocking. Okay, asynchronous operation, sender may send without knowing when the message will be received or read by the receiver. Receiver does not know when the message was sent. This is asynchronous. Synchronous operation, sender knows when receiver has received a message, and the receiver knows when the sender sent the message. Blocking and non-blocking. Okay, blocking communication operation. The process is blocked until the communication operation has completed. Okay, non-blocking communication operation. A process may continue with the next instruction without waiting the communication operation has completed. Okay, the unblocked process can always find out the status of non-blocking operation using test and wait function. Okay, this one quite familiar if you learn Java. Okay, this one we call Java NIO. We have a non-blocking IO. Okay, and also here also in MPI also we have this mechanism to implement this parallel. Okay, so all non-blocking operations should have a matching wait operation because some system cannot free resources until wait operation has been called. Point-to-point mode. MPI communication function. For this MPI send, okay, synchronous sends, message goes directly to the receiver. Process only complete when the receiving operation has begun. Okay, MPI B send means buffer send asynchronous. Message is copied into a buffer provided by the application with some buffer attached the size, and always completes irrespective of receiver. Okay, this one for non-blocking, and blocking also for non-blocking and non-blocking. MPI send, standard send, asynchronous and asynchronous modes. Message may directly go to receiver or go to a buffer, provided by MPI. Thus, it is fixed size buffer. And MPI resend, non-blocking operation. Ready send, assume the receiver is ready, always complete, irrespective of whether the receiver was ready or not. And then for MPI receive, and also we have MPI data type, MPI com, only complete when a message has arrived. Blocking, this is one of our blocking operations. Okay, so we cannot interrupt this, yes? Blocking and non-blocking. Sending and receiving messages. The basic function for sending and receiving messages are MPI send and also receive. Yeah, MPI send data stored in buffer, and MPI receive a message sent by process. It will return to sender only after the message has been received and copied, yeah, to a buffer. This example, okay, example of this. Yeah, MPI this initial environment, okay, and then find out the rank, and then if rank 0, number is equal minus, and then MPI send, okay, to this, else equal 1 and receive. Yeah, one for receive, other one for send. Okay, receive, send the number. Okay, send the number, okay, from rank 0 to the rank 1. And what are the value they send? And then print, process 1, receive the number, and process. And then this process, R0 will send this value to R1. Okay? All right. Okay, this is an example of exercise. Okay, write a program that implement the flow of the event. For example, there are two processes, P1 and P2. P1 requires user to type two values, yeah, X and Y. Okay, you type X and Y and send those values to P2. Okay, P2 will solve this equation. They will not just receive, they will do, what you call this, add these two value and display on the screen. And display the value total on the screen. Okay, we're trying to do this. Okay, all right. So this is the code. Okay, you can try this. Okay, this one happen in one machine. Okay, all right. Because this is not programming, network programming. Maybe in network programming we can implement using another machine to send. Okay, because we need to using a socket and so on. Okay, this one happen in one machine only. Okay, so no need to think about the socket and so on. Okay, so the concept of parallel is there. Right, you can try to explore this. Wildcarding. In some cases, some process may need to receive message with wildcard mode, yeah, from one source. Okay, and then with any tag. We have MPI also. MPI with any source, MPI with any tags. Okay, this is implemented by applying the MPI any source and also this in MPI receive function. Okay, so this one MPI receive function, and this is the value of the source and also the any tag. MPI any source here, MPI any tag in here. Oh, in between, eh? Okay. All right. Oh, wildcard mode. It's quite interesting. Okay, information in MPI status data type, receiver process may find out the sender process. Yeah. ID and message tag number of communication from MPI status parameter of the MPI receive function. Status.mpi underscore source hold the rank of a sender, which is a source ID, process of the communication. Yeah. Status.mpi underscore tag holds the tag number of the communication. So MPI receive. So at the end is MPI status in here. Yeah. Okay. Okay, this is the code. Okay. Using MPI status. Right. So measure program execution. Yeah. Execution. Record the beginning and the finish time using double MPI. You can use this also to record the beginning and the finishing time using this function. Yeah. Okay. All right. You can do record. Also, this is one of the example. You can try this. And then blocking and non-blocking communication. Implementing blocking communication result processes is in block or waiting state. Processes may only proceed to the next instruction when the communication is completed. Okay, in some cases, it is better to allow process do next instruction without have to wait for the communication to complete. Okay, so we pass another resources to another processes to use without we stop or we complete. Okay, so that's why we can do this parallel and also simultaneous whatsoever. Okay, at the same time we can running parallel, yeah, all the process because of this function, yeah. Therefore, implementing non-blocking communication is one of solutions for this issue. Non-blocking communication function in MPI to allow to proceed with the next instruction after calling the communication function and check its completion sometime later. Yeah. Phases in non-blocking communication implementation. Phases in non-blocking communication. We have phase 1, initiate non-blocking. Phase 2, working on other operation. Phase 3, complete the non-blocking communications. Okay. Okay, point to point, which is non-blocking communication function. Yeah. Okay, we have this. Okay, if you can see MPI, this one for this. Yeah, status. MPI send, receive, wait, test, request, and wait, test, wait all, test all, and wait some, test some. Okay, this is non-blocking communication function. Okay, step 1, initiate the non-blocking communication. Okay, couple of set of instruction function. You can see MPI I send, IB send, IS send, IR send, I receive. Okay. Phase 1, initiate the non-blocking communication. Sender side, start standard send. Yeah. This is the command. Synchronous send, buffer send, and also ready send. All right. Phase 1, initiate the non-blocking communication receiver side, which is this. Yeah. And for receiver side. Phase 2, working on another operation. The main purpose of implementing non-blocking function is to allow the process to proceed with other operation instead of being blocked at the communication operation. Yeah. Therefore, the other operations supposedly be implemented in this phase. However, this phase is optional. Status of communication operation is unknown during this phase. Note that there is no status parameter in phase 1 non-blocking function. Yeah. Phase 3, completing the non-blocking communication operation. Since status of the communication initiated in phase 1 is unknown and resources allocated to the communication is not released yet, therefore it is a requirement to complete the non-blocking communication by implement any of the following MPI function. Okay. So this is the what you call this, the function. Okay. For test function allow the process to proceed with other operation after initiated the communication and regularly check the status of the communication. Okay. All right. MPI test, this one, MPI with all, and also MPI test any, and MPI test some. Flag is a Boolean variable. Flag equal true means the communication have completed. Okay. And for wait function are used when process has no other operation to do and ready to wait the communication to complete. Okay, we have function MPI wait all, MPI wait any, and also MPI wait some. Okay. Non-blocking for wait, calling a wait function just after initiate the non-blocking communication, which is number 2 phase, phase 2, yeah? No, it's supposed to be no phase 2, yeah? Yeah, it's equivalent to blocking communication. Okay, using this function, yeah? And then MPI request free. MPI request free is used when to abort the communication and release the resources. Okay. So we need to manage by ourselves this, yeah. Non-block example 1. Okay. So we have few example here. Okay. Send data out to P1 and P2 consecutively. Correct. This one, yeah. Okay. And we have a buffer size, and this one is the number of the process and request complete, and finally and request complete, and what happened, they will print and also wait status, this one, else we print. Yeah, okay, you can try this one. Yeah, so this example of the output. Okay, so you can try this one. All right, this is one of the example, very simple. Okay, maybe okay, maybe you can ask this, not sure whether in exam or not. So this way we will decide. So I will let you know, yeah, our exam, our first test, yeah, for this subject. Write a simple program to send element of an array to a slave processors, yeah. Slave process compute the sum of the element sent and pass it back to the master process, and the master process compute the summation of the result obtained from the slave processes. Similar, yeah, similar like process 1, process 2. Okay, we do this one in array. They need an array to slave. They must send element of array, and then maybe sum of the number integer in the array, and then we sum all this, and then the result we pass to the sender back. Okay, so that's it means by this, yeah. Okay, so I think we have some example at the beginning just now. P1 and P2 send a simple one. Okay, you can try to using a array. Okay, this one exercise 5.2. Okay, I think we stop here, yeah? We stop here. Let me shut this first, record.